Hey, I'm going to be starting a build of a tremolo pedal. I've been building pedals for many years. I've probably built about 15 or so, and about 5 amps, so I thought maybe it'd be nice to start documenting them and showing how it's done. So this is a tremolo pedal. It's based on the Electronics Audio EA Tremolo, which was then adapted to the Build Your Own Clone BYOC Tremolo. So some guys over at tagboardeffects.blogspot.com went and took the schematic and turned it into a veroboard or stripboard schematic. What is stripboard? It's a really cool way of being able to come up with PCB-esque designs without actually having to get a printed circuit board made specially for each circuit. It looks like this. If you take a look, you can see there's little tracks of copper. Not sure if the camera's going to pick it up, but little tracks of copper that run across it. So basically anything that you connect on a line is going to be electrically connected. So you can use that, and basically I can just buy this in bulk and cut it down to size whenever I want to make a new board or something. And so that's how it's going to be done. I'm going to be building 2 of these, one for me, one for a friend. So I'll show the first step, which is cutting this down. Now that we've perforated the board, we should be able to just snap it. Word of warning, you should always have proper ventilation when you do this and wear a mask, because these boards are made of fiberglass, I think, and when you break it, it will send out fiberglass fibers, particles. If it gets in your lungs, it basically never comes out and can cause problems over time. So let's snap it, and then afterward we're going to cut it into... so this is just doing the vertical cut. Next we're going to do horizontal cut, because each of these boards should be 20 by 10, and like I said, I'm making 2 of them because I'm making one for a friend. Alright, so now we have 2 veroboard pieces. Each one of them has 10 copper tracks. Each copper track has 20 holes in it. Which is what this particular one calls for. By the way, if you want to find these, just search on Google, search for BYOC Tremolo Vero, and you'll find this. And you can search for just about any pedal or any type of pedal, and you'll probably find there are a lot of them out there that have been reverse engineered like this. I've made quite a few pedals like this. We're going to be using these, right? And sometimes we don't want the copper tracks to connect all the way across. Inside these diagrams, there are little red boxes. That means that you should cut the track somewhere in the middle. That way, left side does not connect electrically to the right side. So to do that, we're going to use a little drill bit and just gouge out a little bit of that copper foil just so that there's no connection. And then we can go in and take a multimeter, set it to continuity mode, test both sides right next to each other, and make sure that they don't beep. That way we know that the severing the connection that we did was successful. Alright, so now this each of these boards is entirely cut out. You can see all the little places where I gouged out. Trying to get it to focus here, where I gouged out some of the copper traces, and then I went through and I tested each one to make sure that everywhere has an electrical connection that I expect to, and everywhere does not have an electrical connection that I don't expect to. That is, on this side of like this second trace from the bottom down here does not connect electrically to this side, etc. like that. So next step is we did the cuts. Next step is the links. Now that's to say some of these traces we want to connect vertically to other traces, and so we're going to run little jumper wires around the other side of this so that certain ones of these are connected electrically. So to do that, we're going to get a whole bunch of little wires, and we are going to solder them in. By the way, when soldering, you can see me using this. I like to use liquid flux. I find it just helps the solder to flow better, adhere better, make for better joints that are not cold solder joints, which are going to cause you tons of problems down the line. Yeah, definitely recommend getting a little bottle of it, a squeeze bottle. You can get these super cheap. And it seems like a pain at first, but apply it before every solder joint and it makes it much easier. You don't have to use liquid flux, but I really do think it is worthwhile to use. Also, you'll notice that when I'm going through and testing everything with my digital multimeter set to continuity mode, which, by the way, checks to see if things are electrically connected, I will test both the things that I make sure that I want to be connected and also adjacent things to make sure they are not connected, because it's very easy, and I've had bugs before, where a little bit of solder drips from one of these little tracks onto the other one, and that creates an electrical connection. And they're hard to track down. So if you nip it in the bud really early, just test everything. Make sure that that the tracks next to each other are not connected if they're not supposed to be. Makes it way easier down the line. So next step is going to be we will get all the components that we have, and we're going to populate this board. And we're going to put everything on and arrange it, and after we're going to go through and we're going to solder all the components on, and that will be a functioning board. Alright, so I'm done soldering all the resistors on, although actually I'm missing one resistor, 2M2, because I don't have it and I just ordered it, so it'll come in shortly. But anyway, all the rest of the resistors are on, and next up I'm going to solder all the capacitors on. Oh, also I'm going to put the diode in. There's one diode in the circuit. There's also an LED, but that comes later because it's going to be on the outside of the pedal, and there's a little bezel that we're going to put into the chassis of the pedal as well. But this one goes directly on the board. Alright, so pretty much everything's on the board now. The diodes, the resistors, the capacitors, the transistors. Now we're going to start attaching some wires to the board to get the signal in and out, to get the signal from the potentiometers in and out, LED, etc. Alright, so the board is completely assembled now, so we want to test it and make sure it works before we house it in an enclosure. So I rigged up a one of my breadboards to have the device plugged into it, have wires leading to little jacks for input and output, have it put a battery clip on so we can power it, and we'll test it with a guitar into an amp and see how it sounds. So I've run my test now, and I know that the circuit works, which is great. Another good thing which came out of this, I noticed that on the depth knob, basically from 25% of turning the knob ends up with like basically the circuit being completely on and off, like whereas I wanted more of a subtle kind of thing going on. So based on that, I've decided to make a few changes to the circuit. Namely, I think what I'm going to do is the circuit calls for a 1 mega ohm potentiometer, and you sweep through the entire way, and that's the full voltage divider, which is giving the signal to the tremolo, to the transistor, which is pulsing the signal. I think what I'm going to do is use a potentiometer which is much smaller, maybe a 250K one. And then bias it with another resistor on it to take up the rest of that 1 mega ohm portion. So that'd be something like 250K with. I was messing around with 250K with a with either an 820K resistor on the leg, or maybe a 250K potentiometer with a 1 mega ohm resistor on the leg, or I even tried 1.5 mega ohms. Not sure which one I'm going to go with yet, but one of those, and that way it's going to bias it so it's a more usable range across the sweep of the potentiometer. Okay, so eventually we're going to want to put these inside of a stomp box enclosure, so I got these. There are 2 of them, but this is one plate, back plate. So what we're going to need to do is drill out all the holes that is eventually going to need to go on this, right? Hole for the pedal, hole for all the knobs, hole for the LED, hole for the power jack, hole for input and output. I think that's about it. So, I printed out some templates. You can get these, I think, from General Guitar Gadgets and print them out. For this is a 125B size box. I like them the best because they are big enough so it's easy to fit stuff inside, and but not like double-sized boxes or anything like that. Anyway, you can get these. Look for 125B size drilling enclosure templates, and you can print them out, put them on, and it makes it easy to get these to drill in the exact right location, so it's all nice and symmetrical and everything like that. So we're going to do that now. Alright, so the template is all cut out and now taped onto my 125B size box. You can see they have a lot of different options here, right? Depending on if you want 2 knobs, they have drill places here, 3 knobs, be like that, switches, LEDs, anything else you want. Well, not anything else, but a lot of different variety. Various places for if you have a stereo pedal or other such things. A lot of people like to put the input jacks on the top. I do not. I think it's really annoying trying to cram it all into this tiny little space over here, and then even more annoying to run cables which have to go to the top of that. So I always usually will use the side areas for drilling the input and output jacks. Sometimes I'll use the top for the DC input jack. Sometimes I'll use the side. Depends. Now we are going to drill this out. Okay, so using those templates, I drilled out the enclosures, and so now, and I also sanded it down with 220 grit sandpaper, washed it off with some mineral spirits. Now I have to go outside and prime it. I'm going to use a self-etching primer, followed by a coat of paint, followed by doing some spray paint effects on top. and I'll show you what it is, and hopefully it'll turn out okay. Also, I guess it's worth noting that sometimes I spray paint first, and then drill. Sometimes I drill and spray paint. I felt like doing it this way this time. Yeah. By the way, just a little update. I know I said I was using self-etching primer, and I did end up using that for this project, but that was sort of an experiment. I never really did it before, because I couldn't source it before. But it ended up actually not working well. As you can see later in the video, it ended up being maybe not adhering too well, and it caused some little chips that happened that I had to fix later. So in the end, probably I'm going to end up going back to normal Krylon or whatever I use, normal white primer instead.
Alright, so I have my enclosures. I'm going for, this is called the shade tremolo, so I'm going for a shade effect. I taped off some areas where I want the blue to remain the dark blue. I'm going to spray some light blue around and see how that goes. I tested a little area on this box. This piece of tape used to be over here. It seems like it kind of works. Maybe I could spray a little more, not sure. But it does get the effect I think I'm going for, so we'll try that on the actual enclosures. Come take a look. Real close.
Looks pretty good, I think. Okay, so my wife added text onto these. We, use the knobs and everything in order to figure out exactly where it should go. Yeah, so this is all just about ready for clear coating. So once the weather is good enough, we are going to take these outside and apply a few coats of clear coat, and then it should basically be done, and we just have to do the assembly.
So we did the clear coat, and then I ended up actually dropping this, and you can see there are a few chips here. I'm going to try to fill it in by spraying some spray paint, and then taking a Q-tip, dabbing it down, and seeing what happens.
What do you think? Not bad? We managed to actually fix some of the problems we were having before by first we took a we pooled some of the dark blue spray paint and then used a Q-tip in order to fill in some of the base layer. Then we took this paint pen and we made a little pool of its paint. Took a toothpick and made tiny little taps. Honestly, you really can't even tell there's a problem on the video. I think in person, if you look really close, you might be able to see some problem, but maybe not even. It's pretty good. Right now, looks very much like it did originally. So really pretty glad we managed to make that work and didn't ruin this project just by dropping this thing. We managed to fill in some of the stuff over here. This wasn't due to dropping, but there was this line on the right side of this was not entirely straight, just because of the way I layered the tape. And we managed to fill that out with can't get to focus. Managed to fill that out with some with the same technique with the paint pen. So pretty happy with how that came out.
Alright, I've laid everything out in here. I think I'm about ready to start wiring up the pedal.
Alright, so I'm currently wiring this up. You can see I'm twisting some of the leads together to keep it neat, and trying to cut them down to a good length. Wiring them up so that, according to the wiring diagram in the veroboard layout, wiring it to the input jack, output jack, switch, which switches between true bypass and engage mode. This is the 9-volt socket. Interesting thing here is you see I have a 9-volt battery, right? So it can take both. Interesting thing about these sockets is that they're switched, right? So that when you don't have anything plugged in, it will go to the battery. But when you do have something plugged in, it will disengage the battery terminal. You have to know which one to solder to, which is that one, the second one in, and then it will engage. It'll just take power directly from the wall, the DC adapter that you have plugged into this thing. Another interesting thing is the way you can do this. Sometimes people use switch jacks in order to make sure that the power cuts out when you don't have anything plugged in, because you don't want to run out your battery if you forget to if you don't actually have anything plugged in, right? So one cool way of doing that is you can take of course, guitar cables, they're just TS, right? They're mono tip sleeve, but you can take a TRS plug, right? And when you use one of these, if you use a mono one with it, it actually shorts the ring and the sleeve, the R and the S together. And you can use that as a means of, if you plug the ground into this, right? I have the ground running from this jack into the R over here, the ring. So it won't actually make a connection, and the battery will not be run out unless you plug in something which shorts the ring to the sleeve, which is exactly what happens when you have a mono cable. So just little tricks you pick up here and there to avoid having to buy expensive switched jacks if you don't need them and stuff like that. Okay, so now I've made all the final connections, put everything together, screwed on the back plates, and basically we should be ready to give it its final sound check. It's dry tone.